We're going to continue with multiplication of polynomials, but we're going to look at some special products. So all of the problems on this page have something in common. They're a binomial raised to the second power, right? So a binomial squared. So they are actually called binomial squares. I like to call them mistake makers because students tend to forget what a binomial square actually does, and they make mistakes. So I'm not even going to write it down, but if you were thinking that this should be x squared plus 9, you are making a mistake. Whenever we have addition with a power on the outside or subtraction with a power on the outside, there will be work to do, more work than you probably think. So the meaning of this x plus 3 squared is x plus 3 multiplied by itself. So we can see that this is actually a FOIL problem. So we have x times x, x squared, x times 3, 3x, 3 times x, 3x, and 3 times 3, 9. So x squared plus 6x plus 9. So indeed, there is x squared, and there is 9, but if you just did x squared plus 9, you would be missing the middle term. This one means 2x minus 5 times 2x minus 5, which would be 2x times 2x, 4x squared, minus 10x, minus 10x, plus 25. So 4x squared minus 20x plus 25. This one means 4x to the third plus 2/3 multiplied by 4x to the third plus 2/3, which would be 16x to the sixth plus 8/3 x to the third plus 8/3 x to the third plus 4/9. So 16x to the sixth plus 16/3 x to the third plus 4/9. So when we have the square of a binomial, we always end up with a middle term. And that middle term, if you notice, is what they say double what the two terms in the binomial would be multiplied. So x times 3, we got two sets of 3x, so 6x. 2x times negative 5 would be negative 10x. Two sets of that would be negative 20x. Multiply these, we get 8/3 x to the third, but we have two of those, so we have 16/3 x to the third. So some people use patterning to solve these. Some of them just write it out and use FOIL. This is two binomials, but they are kind of special because one of them is x plus 3 and the other is x minus 3. One of them is 2x minus 5 and the other is 2x plus 5. One of them is 4x to the third plus 2/3 and the other is 4x to the third minus 2/3. These are actually called conjugates. Because although the first term stays the same, the second term is the opposite. And something happens when we multiply binomial conjugates together. So let's multiply. We get x times x, x squared, x times negative 3, negative 3x, 3 times x, positive 3x, and 3 times negative 3, negative 9. Notice what happens here with our outside and inside terms. They're opposites, so we just end up with x squared minus 9. Let's see if that happens again. 2x times 2x would be 4x squared. 2x times 5 would be 10x. Negative 5 times 2x is negative 10x. And negative 5 times 5 is negative 25. Once again, our outside and inside terms are opposites, so they cancel out. 4x squared minus 25. One more time, just for fun. 4x cubed times 4x cubed is 16x to the sixth. 4x cubed times negative 2/3 would be negative 8/3 x to the third. 2/3 times 4x to the third would be positive 8/3 x to the third. And 2/3 times negative 2/3 is negative 4/9. Again, these cancel out, and I'm just left with 16x to the sixth minus 4/9. When I multiply conjugate binomials, I get an answer which mathematicians call the difference of two squares. Because it is. That's a square, it's x squared, and that's a square, that's 3 squared. That's a square, that's 2x squared. That's a square, that's 5 squared. That's a square of 4x to the third, and that's the square of 2/3. So some people do these problems also by patterning. They say, well, it's just going to be x times x squared, 3 times negative 3, negative 9, because the outsides and insides are going to cancel out. Third thing in this lesson would be, okay, if we're not going to make a mistake with the square of a binomial, would we make a mistake with the third power of a binomial or the fourth power of a binomial? And the answer is heavens no, we won't make a mistake because we know that this is x plus 5 multiplied by x plus 5 multiplied by x plus 5. This is a lot of work. I think I'm going to start, well, I can start anywhere, so I'll start here. This one is x squared plus 5x plus another 5x, so that's plus 10x plus 25. And I still have to multiply that by x plus 5. I think I'm going to use my multiplication table strategy. Got x squared, 10x, 25, an x and a 5. So this is x to the third. This is 10x to the second. This is 25x. This is 5x squared, 50x, and 125. On the diagonals, I have my like terms, x to the third plus 15x squared plus 75x plus 125. Done.